day everyone and welcome back to DepEd TV. I am Teacher Joshua and I will be your guide in sharpening your skills and enhancing your mind in order to face the challenges here in Grade 8 Mathematics. Ready your self-learning module, your paper and pens with you, and we will have a wonderful day of multiplying and dividing rational algebraic expressions. Last episode, we learned how rational algebraic expressions can be written in simplest form like fractions. We can simplify them by factoring the numerator and denominator, then dividing both by their common factors. This skill is very helpful for our next topic. But before that, let us look at this. Today is Mel's birthday, and to celebrate, he is preparing a cake. Let us help him identify the following fractions. What part of the cake is 1/2 of 1/2? To check, we divide the cake into 2 parts and get 1 part of it. Hence, a half. But what we need is the half of the partition of the cake. By this illustration, what is 1/2 of 1/2? If your answer is 1/4, then you are correct. We can also show this mathematically by multiplying 1/2 times 1/2. Do you still remember how to multiply fractions? We multiply the numerator of the first fraction to the numerator of the second. 1 times 1, which is equal to 1. And multiply their denominators. 2 times 2 equals 4. Then if the fraction can further be simplified, we write it in its lowest term. So, 1/2 times 1/2 is 1/4. This is similar to multiplying rational expressions, but it will be much easier if we simplify the fractions before multiplying. What is the product of 15y over 2y times 4y over 5x squared? Again, when multiplying fractions, numerator by numerator, and denominator by the denominator. So what is the product of 15y times 4y? That is 60y squared. How about the product of the denominators? 2y times 5x squared is 10x squared y. Can the expression be simplified? We can get the greatest common factor of the numerator and denominator. It is 10y. So what are we left with? 10y times 6y over 10y times x squared. And dividing the common factor, it will become just 6y over x squared. That is how we multiply rational expressions whose numerator and denominator contain monomials. So how about this one? Multiply x squared minus 4 all over 2 times 4 over x minus 2. When the rational expression has polynomials with 2 or more terms in its numerator or denominator, it is better if we express them first in factored form if possible. So which expressions can be written in factored form? If you noticed, x squared minus 4 is a difference of 2 squares. What is its factored form? So we will have x plus 2 multiplied by x minus 2 all over 2. How about the second multiplier? The numerator 4 can be written as 2 times 2. Then rewrite the denominator x minus 2. Do you see common factors? Dividing the common factors, what are we left with? We are left with 2 times the quantity x plus 2 all over 1. And what is this product? it is equal to 2x plus 4. Let us have another example. What is the product of x minus 5 all over x squared minus 7x plus 10 times the expression x squared plus x minus 6 all over 5? Since there are several terms in the numerator and denominator of the algebraic fractions, we can write them first in factored form. Can we factor x minus 5? No, it is already a prime polynomial, so we just rewrite it. Next, what are the factors of x squared minus 7x plus 10? What could be factors of positive 10 whose sum is negative 7? Negative 2 and negative 5. So we can express the trinomial as the product of x minus 2 and x minus 5. Then we factor the numerator x squared plus x minus 6. Which two factors of negative 6 can have a sum of positive 1? The factors are negative 2 and positive 3. So we can write this as the quantity x minus 2 times the quantity x plus 3. And since the denominator is just a constant and the prime number, we write 5. Now, what are the common factors that we must divide? We divide x minus 5 and x minus 2. So what is the product? It is x plus 3 all over 5. Let us apply your knowledge in multiplying rational expression in a simple word problem. During a pandemic, helping hands are always around. A youth group decided to distribute relief goods to different places. A member was allowed by his parents to use a vehicle for their distribution. If they travel at a speed of 30 kilometers per hour, how far will the youth group reach after 25 minutes? What is asked in the problem? We are asked to find the distance they have traveled in 25 minutes at a speed of 30 kilometers per hour. Distance is just equal to the product of the rate or speed of the vehicle times the time it traveled. So we just multiply 30 kilometers per hour by 25 minutes. But wait! We need to convert 25 minutes into hours so we will not have conflict in our units. To convert, we multiply it by a conversion factor. So we will have an equation of d, or the distance, equal to 30 kilometers over 1 hour, the speed of the vehicle, times 25 minutes over 1, since it is a whole number, and times the conversion factor 1 hour over 60 minutes because there is 60 minutes in an hour. Then, what will be the product of these fractions? It is 750 km/h over 60 hours. Dividing 750 by 60 and the common units, what will we have? We will have 25 over 2 or 12.5 kilometers. We are done with multiplication. Now, how about its inverse? How do we divide rational expressions? Division of rational algebraic expressions is similar to dividing fractions. So let us try 2/3 divided by 1/2. Remember that when dividing fractions, we get the reciprocal of the divisor and change the operation to multiplication. The reciprocal of a number is the multiplicative inverse of that number. To get the reciprocal, we interchange the terms in the numerator and the denominator. For example, let's have 4/7. The reciprocal of 4/7 is 7 over 4. Now let us try to get the reciprocal of 11 over 5. The reciprocal of 11 over 5 is 5 over 11. Now let us try to divide the following fractions. What is 2/3 divided by 1/2? Again, we get the reciprocal of the divisor and change the operation to multiplication. So this operation will become 2/3 times the reciprocal of 1/2, which is 2 over 1. Then we multiply the numerator by the numerator and multiply the denominator by the denominator. So what is the product? 2 times 2 is 4, and 3 times 1 is 3, or 4/3. Now we can apply this concept in dividing rational algebraic expressions. Divide and simplify x plus y all over x minus y divided by x over y. First step is to get the reciprocal of the divisor and change the operation to multiplication. So we will have x plus y all over x minus y times y over x. Can we factor the polynomials? There is no need to factor the polynomials since they are relatively prime. So we proceed by multiplying the numerators. What is the product of x plus y and y? It is xy plus y squared. How about the denominator? It is x squared minus xy. So the final answer is the rational expression xy plus y squared all over x squared minus xy. Let us have this last example of dividing expressions before we move to our exercise. Find the quotient in x squared plus 5x plus 6 all over x squared plus 4x plus 4 divided by x plus 3 all over x plus 1. First is to get the reciprocal of the divisor and change the operation to multiplication. What is next? We can factor the trinomials and divide common factors. What are the factors of x squared plus 5x plus 6? I'll give you a hint. The first one is x plus 2. The other factor is x plus 3. How about the denominator? This is a perfect square trinomial. So what are its factors? It is the square of x plus 2, or x plus 2 times x plus 2. Do you see common factors that we can divide? The common factors in the numerator and denominator are x plus 2 and x plus 3. Now, what is the quotient? The final answer is the rational expression x plus 1 all over x plus 2. That's it for today. We now know how to perform multiplication and division on rational algebraic expressions. Now let us have a recap.
Given rational expressions a over b and c over d, where a, b, c, d are polynomials and b, d are not equal to 0, the product of a over b times c over d is equal to the product of the numerators ac all over the product of the denominators bd.
In dividing rational expressions, we get the reciprocal of the divisor and proceed on multiplying the two expressions. So a over b divided by c over d can be expressed as a over b times d over c, which is equal to the product of the numerators ad and the denominators bc. Remember that we can simplify the expressions by factoring and divide common factors so the process can be easier. Ready your paper and pens and analyze each question carefully. I will give you 5 seconds to answer each item. You should also solve the problem with me as I guide you along the way. Number 1.
Which of the following is the product of y cubed over x cubed times x squared over y squared?
Is it A, x over y, B, y over x, or C, x raised to 5 over y raised to 5?
To get the product, we can actually simplify the expression by writing it using prime factorization. Then, we divide or cancel common factors. The answer is y over x, letter B.
Number 2. What do we need to do with the divisor when dividing by a fraction or a rational algebraic expression? A. Get its additive inverse. B. Get the multiplicative inverse. Or C. Get their common factors. The answer to this question is B. Get the multiplicative inverse or the reciprocal, then proceed to multiplication. Number 3. What is the divisor in the operation 2x minus 4 all over 3 divided by x plus 5 all over 3? Is it A, 3, B, 3 over x plus 5, or C, x plus 5 all over 3? The divisor in this operation is the second expression. So the correct answer is letter C, x plus 5 all over 3. Number 4. What is the product of x squared minus 9 all over x squared plus x minus 20 times x squared minus 8x plus 16 all over 3x minus 9? Is it A, x squared minus x minus 10 all over 3x plus 12? B, x squared minus x minus 12 all over 3x plus 15? Or C, x squared minus x minus 14 all over 3x plus 18? We can start the solution by factoring each polynomial in the numerator and denominator of the rational expressions. X squared minus 9 is equivalent to the product x plus 3 times x minus 3. While the denominator is equal to x plus 5 times x minus 4. Take note of the signs of your factors to avoid mistakes. Then the next numerator, x squared minus 8x plus 16, is a perfect square trinomial. What are its factors? It is x minus 4 multiplied to itself. How about the denominator? It has a greatest common monomial factor, 3. So it can be expressed as 3 times the quantity x minus 3. We now divide the common factors and multiply the expressions that are left by FOIL method. So the final answer is letter B, x squared minus x minus 12 all over 3x plus 15. Number 5, find the quotient in x minus 2 all over 2 divided by x minus 2 all over 5. Is it A, 2/5, B, 5/2, or C, 10. We divide this by getting the reciprocal of the divisor. The reciprocal of that expression is 5 over x minus 2. Then we multiply the expressions. Observe that they have common factors in the numerator and the denominator. So what can we do? We can now divide them to simplify the operation. What will be left? So the correct answer to this is letter B, 5/2. Did you get the exercise? Very good. If not, I suggest that you review factoring polynomials and simplifying rational expressions, and keep on polishing your skills with the examples and assessment found on your self-learning module. Remember that in mathematics, practice makes you better. For our next episode, we will perform another set of operations, adding and subtracting rational algebraic expressions. Remember, math is not only about numbers and operations. It is an exercise for our minds for us to be critical, logical, and responsible thinkers. Again, this is Teacher Joshua reminding you to keep safe, have a nice day, and see you next time.